Today's daily LeetCode problem of the day is find the kth smallest pair distance, number 719. This problem, the distance of a pair of integers a and b is defined as the absolute difference between a and b. We're given an integer array nums and an integer k. We want to return the kth smallest distance among all the pairs. Nums in I and nums in j, where 0 is less than or equal to I, which is less than j, which is less than nums.length. So if we look at example 1 here, our example is 1, 3, 1, and k is 1, meaning we want to return the first smallest pair. Our output is 0, and that is because 1 minus 1 is 0. So nums 2, 1, 1, 1, we want to return the second smallest pair, however, all the pairs equal to 0, so we return 0. This one, k is equal to 3, so we have 6 and 1, 1 and 1, and 6 and 1. So the smallest distance, the third smallest distance is 6 minus 1, which is 5. So we look at the constraints. N is equal to nums.length, as long as 2 is less than or equal to n, which is less than or equal to 10 to the 4th. 0 is less than or equal to nums of I. Okay, so it's going to be very limited time-wise and size-wise. So we are going to use kind of a two-pointer binary search method. So how are we going to do this? We're first going to sort our array, and then we're going to identify a low and a a low, mid, and high, so we can kind of determine whether or not our kth value is going to be on the left or right of mid. So k is going to be on the left or right of mid. With that information, we can call to a helper function to find pairs on either side of mid. So let's go ahead and program this. First thing we want to do is sort our array. So arrays dot sort nums. We're then going to identify the size of nums, so we can have an int size is equal to nums.length. And then we're going to have an int low is equal to 0, and high is going to be equal to, high is going to be equal to our nums of our, size minus 1 minus nums of 0. So low is going to be equal to 0, and high is going to be our greatest length difference between two variables. So this is going to allow us to do a kind of binary search sliding window method, because we know the greatest difference as well as the smallest difference. So if we want to find the kth smallest difference, we kind of have to locate where that kth difference is going to be. So we're going to, that was identifying our low, mid, high, because now integer mid, which we're going to identify in a loop. So while our low is less than our high, so while our smallest difference is less than our highest difference, we're going to have a middle difference. So int mid is going to be equal to low plus high divided by 2. So this is typical for binary search. We identify the midpoint, and we could continuously divide our problem in half. So we're going to look at the left, look at the right, so on and so forth. We're then going to initiate an integer count, which is going to be equal to a helper function called count pairs. And this is basically going to count pairs on either side, where depending on where mid is at, so nums and mid. So if our count is less than k after it returns from count pairs, that means that our kth smallest pair has to be on the right side of mid, as we are currently looking at the left side of mid. So low is now equal to mid plus 1. Otherwise, our high will be equal to mid because our pair has to be on that left side. And then we will be able to return our low. Ultimately, low will stop at whatever our value is because we turn high to mid. So we continuously cut this in half. So we're continuously turning our high to our midpoint, which is halfway through, or we're updating our low to be mid. So we're slowly progressing these two together until they end on the perfect count where we found the kth pair. So now let's call to our helper function. Our helper function is going to be a private. It's going to return an integer. It's called count pairs. It's going to receive an integer array ARR and an integer, and we can call that our distance. That is going to be the distance threshold we want to compare to. As long as our distance is less than this, whatever this middle distance is, we should add it to our count. Otherwise, we need to adjust our left and right pointers. So we're going to have an integer count, which is going to be equal to 0. And our size is going to be equal to arr.length. And left will be equal to 0. We will then have a for loop. So for int right is equal to 0 as long as right is less than our size. We can do right plus plus. So we are once again doing a left and right pointer. Currently they are the same, so probably nothing's going to happen as the distance is going to be 0. But once we start incrementing our right, and the distance between ARR of right and ARR of left gets greater than our distance threshold, we are going to want to increment our left pointer to get back within the valid regions of our distance threshold. We can then increment our count based off of whatever right minus left is, and return that count. So this is a typical binary search, and down here we're kind of having a sliding window. So the sliding window is a left pointer and a right pointer, and as long as the distance between them is less than or equal to the distance threshold that we give this function, we will continue to find those distances. Otherwise, we will have to increment our left pointer. And up here, we're doing a binary search. So as long as our low is less than our high, we're going to find the middle point, and we're going to pass that middle point to our count pairs. If the count is less than k, we will move low to equal to mid. Otherwise, our high will equal to mid, slowly dividing this array into smaller and smaller chunks for us to handle. So if we run this, so this passes our test cases, and if we submit it, passes all solutions. So thank you, and follow for more daily LeetCode solutions. I probably won't be doing Python solutions for a while now. Life is getting busy, but I will continue to try and post these Java solutions. So thank you.